Physicists have long theorized that there is a subatomic building block that exists.
Excitement and relief as the Large Hadron Collider subsystems whir back into action.
CERN just switched on a neutrino field, and scientists fear they've woken something they can't control. Deep underground, invisible particles are suddenly changing their rules, sending shockwaves through physics. Researchers thought they understood the risks, but strange signals now whisper warnings of something much bigger. Tune in because those blinking detectors just showed signs that the universe itself is breaking apart. The machine that whispered to ghosts. This isn't about smashing rocks or shooting lasers. This is about one of the most untouchable things in the universe finally getting poked by a stick. Tiny particles that fly through your body by the trillions every single second without hitting anything. Ghost particles. Now imagine trying to grab them, bend them, twist their path, and maybe even make them do something they've never done. That's what just happened. The scientists didn't just build a machine. They flipped a switch and turned on a field. Not like a field of grass. A field that decides how these ghost particles act. And for a few seconds, the universe blinked. They called it a neutrino field, and it didn't stay still. This isn't the first time these folks have done something wild. This lab has been messing with the limits of physics for decades, but this one hit different. Something about this one has got even the old school experts twitching. You'd think people who spend their lives on math wouldn't freak out. But here they are, pacing hallways and triple-checking papers. The whole idea is this: the ghost particles are slippery. They don't stop for anything. They pass through walls, through people, through the earth. That's why they're so hard to study. But deep underground, in this bunker surrounded by wires and metal and silence, scientists figured out how to mess with the field these things live in. Not catch them, not control them, but tweak the place they exist, like changing the rules of a game without touching the pieces. That's what they turned on. This field connects to every ghost particle out there. And the moment they powered it up, they didn't just light a match. They lit a match inside a fireworks factory, unsure which box was going to blow. It gets weirder. These fields aren't just empty space. They're the code behind the world. Every bit of matter, every force, every twitch of movement comes from one of these fields doing something. When you touch the neutrino field, you don't just change neutrinos. You risk messing with the fabric itself, the threads everything else is sewn into. That's what has scientists whispering, not yelling, whispering, because they don't want to sound paranoid, but they're uneasy. Picture this: you've got a puzzle holding itself together, a big, beautiful, ancient puzzle. No box, no manual, just pieces that somehow fit. Now you're not moving a piece, you're heating up the table. You're changing the air, and you're hoping the puzzle doesn't fall apart. That's what activating this field felt like. Some folks say the payoff is huge. They talk about new physics, new rules, maybe answers to questions we've been chasing for 100 years. Stuff like why matter even exists, why the universe didn't just vanish in a flash the moment it started. But they also admit something else. They don't fully know what they turned on. Sure, they ran simulations, math stacked on top of math, but none of that tells you what a real field is going to do when it's been left untouched for billions of years, and then suddenly gets a pulse shot through it. The people in the control room said it went smooth. No explosions, no lights flickering. But there were signals, strange ones, measurements that didn't line up, moments where it felt like the field was doing more than just responding, almost like it was shaking something loose. They called it stable. Others called it something else. The word risk started bouncing around, not from internet rumors, from real researchers who don't usually speak out, warnings about balance, about butterfly effects, about what happens when something small spins out into something big, like flipping a switch on a dam, not knowing if the crack on the other side is real or just a shadow. This isn't about blowing things up. This is about waking something, or pushing on a door that no one has ever opened. The field is part of a system older than stars. It doesn't follow our logic, and now it's been poked, stirred, given just enough energy to ripple. The numbers still roll in, more data, more papers, but the feeling's already there. Not fear, not yet, but something colder, like the chill when you realize the ground under your feet is hollow. Down inside the chamber, the detectors were waiting. Huge orange eyes, arranged like a swarm of sleeping giants. Thousands of them, each one tuned to see the invisible. When the field came online, those eyes blinked. Just a little, enough for the team to know something had shifted. Back above ground, some physicists looked at the readings and saw confirmation. Others saw warning lights. A spike here, a delay there. Stuff that shouldn't happen unless something deeper is moving under the surface. Then the data shifted again. Something new crept in. What the ghost particles brought back, they checked the numbers again. Triple checked, but the same odd things kept popping up. Patterns that hinted at something outside their current models. Waves in the data that looked like echoes of something old waking up. They were not expecting this. The field didn't just stay put, it pulsed. It hummed. Not like a machine, more like a living thing, breathing slow. It was as if the field was aware, not alive, not thinking, but reacting. These kinds of fields aren't like wires or magnets. They don't sit still, they ripple, they bleed into other fields. When one shifts, others shift too. That's the worry. That one little nudge could start a chain of effects across the whole table. What if one ripple in this field leans into another? What if the ghost particles aren't just passengers, but messengers? What if they carry the change with them, across the world, through everything? Nobody knows. They only know the readings are strange, and the math for once is quiet. In one of the back rooms, buried under concrete and steel, an old chalkboard has fresh scribbles. Equations rewritten, new terms added. The kind of symbols that mean somebody is trying to catch up to something moving faster than thought. And underneath it all, that silent hum. The fields still live, still active. No switch flipped off yet. Just watchers, monitors, pages of notes, waiting. And far away in other labs, other detectors begin to notice things too. Maybe not connected, maybe not yet, but a delay here, a distortion there, a whisper of movement in places that used to be quiet. This kind of thing doesn't happen because someone had a wild idea in the shower. It's backed by pages and pages of math, layers of theory, and enough past experience in high-energy science to make even the boldest folks nervous. Every time people dig deep into how the world works, strange things show up. Usually no one sees the full picture until long after the sparks fly. And this time, there's a lot more at stake. The lab team is poking at something that might not just show us new things, it might push the whole balance of the universe around. The researchers fine-tune their tools until they hit the sweet spot, where that neutrino field, usually calm and invisible, started to show signs of life. They weren't smashing things together or flipping switches at random. This was precision work. They tuned energy flows carefully, set the environment just right, tweaked the detectors to catch even the faintest signs. It's like listening for a whisper in a thunderstorm and actually hearing it. And the weird part? These particles barely interact with anything. They move through matter like ghosts. Most of the time, they just keep going, untouched and unnoticed. Getting them to react at all is a kind of miracle. But now that they've done it, they're seeing things they've never seen before. Patterns in the noise, movement where there should be none. Tiny reactions pointing to something bigger, deeper, older than anyone expected. Now the field's pulling on more than just particles. The cost of waking the code. Some are calling this a breakthrough. Others think it's asking for trouble. There's a reason folks are cautious. When you start activating fields that only exist on the edge of understanding, even a little mistake could cause something you can't stop. The field is touchy. The setup is complex. Just a small error in temperature, pressure, or energy level could make it behave in ways no one can explain. And once it starts, it might not stop. If the patterns they're seeing don't match what the current rules say, then those rules need to change. That means everything scientists believed about how the universe works might be up for grabs. It opens the door to forces we've never seen, particles that don't belong to the known list, interactions that go beyond every textbook ever written. That's not science fiction, that's the edge of reality, and people are paying attention. This experiment has slipped out of science papers and into living rooms, social feeds, and classrooms. Some folks are amazed. Others are worried. Both sides have a point. On one side, the chance to unlock new ways of thinking, building, living. On the other, the risk that poking too hard might make things break in ways we can't fix. This neutrino field was just an idea for the longest time. A ghost field, something that was there but couldn't be touched or moved. Now it's awake. Now it responds. Now it's being measured. That's the part that makes it real. And now that it's real, scientists are looking at it from every angle, measuring the smallest shifts, comparing them to predictions, seeing if what's happening matches what's supposed to happen. If it doesn't, that means the universe is hiding secrets deeper than we thought. There's already talk of what comes next. Bigger labs, sharper tools, stronger energy sources. Experiments that don't just observe the field, but try to use it. That part is what's making people sit up straighter, because it means the line between seeing and doing is about to blur. Imagine being able to control the building blocks of space, time, and matter. Not just look at them, but actually move them around, bend them, use them. That kind of power isn't small. It could flip how we create energy, change how we move through space, reshape how we think about matter itself. But power like that never comes without a cost. And the cost in this case might be the stability of the world around us. Media coverage has jumped on this like a pack of wolves. Some headlines are throwing around words like universe-altering. Others are warning about unknown risks. They splash big pictures of machines glowing in blue light, with captions promising answers or danger. Everyone's got an angle. But no matter how they spin it, the core fact stays the same. The field woke up. In homes, schools, and science halls, people are arguing. Some say it's the next chapter in human progress. Others say it's poking at a lock that was never meant to be opened. There's no easy answer. Both sides are loud, and both sides have reason to be. Scientists in other countries are watching too, taking notes, making plans, preparing to either build on what was done or put guardrails in place. Some want to push further. Others want to hit pause. The debate's heating up, and underneath it all, the field keeps humming. Are we witnessing evolution or unleashing something we can't control? Like, comment your take and subscribe if you're ready to explore the edge where science meets the unknown.